All right, here we go. So you are going to want something to highlight or denote. Here we go. So we have kind of a lot to do today. So we are looking at 3D figures and surface area today. We want to be able to classify 3D figures and calculate surface area. And so we have some 3D figures. Oh, I should get out my models. There are a couple different types, but the main two types that we want to make sure we really understand are prisms and pyramids. So prisms have two congruent bases, and what we want to understand is that a base doesn't necessarily mean it's on the bottom, okay? The two congruent bases, you know, if my three-dimensional object is laying this way, where are the two congruent bases? It's not the bottom. These are the two congruent bases. This one has hexagons, okay? Whether I hold it this way, these two hexagons are still called the bases. Do we understand? Okay, so it's really important that when you look at a 3D figure like this one, what are the two congruent shapes? Triangles. We have the triangle on top, and we have the triangle on the bottom. So we want to be able to identify those two congruent bases. It's really important. You'll also notice that when you have those two congruent bases, this one is triangles, those two bases are connected by what shape? What shape connects the two bases?
Triangles.
What shape
Square.
is it? Square, and looks like a square. It's a rectangle. And here again, with the hexagons, what shapes connect those two bases? Rectangles, every single time. So when we have a prism, they have two congruent bases, and they are connected by rectangles. And that is really important. All these are rectangular shapes, front, side, and back there. So we have two congruent bases, and they're connected by rectangles, and that's what a prism is. Now, a pyramid is a little easier to recognize because a pyramid always comes to a point. And so here I have an example. This is a square-based pyramid, like those found in Egypt. All right. So these are the Egyptian square-based pyramids. All right. And again, we define the base of the pyramid. A pyramid has only one base, and so in this particular picture, we do have the single base. This base is a square. So our base here is a square. What do you notice about all the sides of the pyramid? They're all triangles. In this particular one, they're congruent triangles. They aren't always. So in a pyramid, we have one base, and then every other shape is a triangle, all right? They're all connected by triangles. The triangles are what come to a point. And so here we have that same triangle-based pyramid, all right? And then cylinders, easy to recognize. It is sort of classified as a prism, though I don't know that I really would. A prism should be made of all flat surfaces, like they should all be straight flat surfaces, versus a cylinder, which of course has some very round portions here. But what it does have in common is that it does have two bases. And again, so that makes it prism-like, I would say. We also have cones. This cone came out of its shell here. So we have cones as well. Much like a pyramid, it's very similar to a pyramid, but it again, has rounded surfaces, makes calculating some things a little bit more challenging. Again, it has a circular base. And then, of course, we have spheres. I have a sphere on me right now, which is, of course, like the Earth. It has a radius, much like every circle. It has a very, very center point, like the core of the Earth. We have a radius that radiates out from the center. And, of course, it can come straight forward. It can go straight down. But a radius always goes from the very, very center. And its radius, no matter which way, if it's coming at you or going behind, it's always the same distance from that center point, okay? And so these are all the shapes that we want to be able to identify. And we're going to classify each, so we're going to give each a name as well as we go through some of these. So first of all, pyramid or prism? Pyramid, because it comes to a point. And we want to highlight the base. So here is our base, and what is that base shape? Rectangle. So we call this a rectangular based pyramid. Rectangular based pyramid. All right. What's number 2 called? A cone. Yeah, that one's easy. All right, that is a cone. And, of course, we want to highlight the base. So, again, that's the circle part. What about number 3? Prism. What are the bases? Little triangles on top. Triangular-based prism would be the name. Very good. Triangular-based prism. What would you call number 4? Hexagon-based pyramid. Hexagon-based pyramid. And again, that is the base. It is a hexagon. We learned yesterday how to calculate the area of different polygons. What did you call number 5? Cylinder. Number 6. Prism or pyramid? Prism. Yeah, what are the bases? Rectangle. Yeah. And so we could, there's lots of bases, because in a prism, a rectangular prism like this, a tissue box is the best example. There's always 2 congruent shapes. In fact, there's 3 sets of congruent shapes. So you've got the top and the bottom. They could be called the bases. You've got the left and the right sides. Those are congruent. They could be called the bases. And you've got the front and the back, and those are congruent, and those could be called the bases. And it doesn't matter. But they're all rectangles, so this is a rectangular prism. It is a rectangular prism, and we can pick whatever bases we want. So I'm just going to use the top and the bottom because they're convenient. Number 7. Trapezoidal prism, yes. Yeah, the 2 congruent bases are in front and back this time. So we have that trapezoid in front and the trapezoid in back. And so you could say trapezoid-based prism or trapezoidal. Trapezoidal prism. All right. Number 8 is a square-based pyramid. And again, it has a base of a square. So the whole point of this is you've got to be able to recognize the bases. So will you please just go ahead and highlight the bases of the last few figures? If you can recognize the bases, you will be very good. All right. So recognizing the bases of figures is half the battle, because we need to be able to recognize the bases to be able to calculate some things. So, any questions so far? Okay, great. There is math involved today, but I'm going to teach it to you in the most simple way, because I don't like to make things complicated when they don't have to, okay? So today, flip the page, we are talking about surface area. We want to be able to find the surface area, Everything we're doing today is finding surface area. What does that mean? What does surface area mean? So perimeter, I get what you're saying. Perimeter is usually just a length measurement, though. And we want area, which... How big the side of it is? Okay, just one side? How much do we add together? We add up all the areas. So surface area means the area of all surfaces, okay? And that is it. That is the goal. We want to find the areas of all of the surfaces. Now, I can teach you 1,000 formulas, but I don't want to, because what do we do when we learn a formula? We forget it, okay? So you already know a lot of formulas for different shapes. For instance, what's the area of a rectangle? Yeah, base times height. Area of a rectangle is base times height. What's the area of a triangle? 1/2 base times height. And let's see, what's the other one you probably need to know? Area of a trapezoid. That's times the sum of base 1 plus base 2. Yes. We have all those formulas on the front side of your notes, okay? 1/2 height times base 1 plus base 2. If you know, oh, and then area of a circle is always a good one too. Area of a circle? Pi r squared, very good. So if you know all of these different area formulas, that's good enough. I don't need to teach you any more formulas, okay? We want to understand our shapes and go from there. So we want to find the surface area of each rectangular prism. I just really need to know about these shapes. And so what I'm going to do, again, is just sort of do a little highlighting here. I can teach you this formula. You can use it if you want. I'm not going to teach you the formula. You can figure out the formula if you want. But I just want you to understand what to do here. And surface area is just adding all the areas, okay? So this is a rectangular prism, okay? And it has how many different faces? 6. Left, right, that's 2. Top, bottom, 4. Front, back, 6. Okay? They all come in pairs. All right? So what we're going to do is, I'm going to go ahead and start by finding these areas here of the two sides, the left and right. How do I find the area of these? What shape are they? Squares. They're not necessarily squares. They are rectangles. All right. So this green rectangle here, I know that one edge is 7. What's the vertical edge there? 9. Okay. You got to use the figure, kind of analyze the figure a little bit. So how do we find the area of the green thing? Base times height, 9 times 7, 9 times 7. And how many of them are there? 2. So because there's 2 of them, I'm going to multiply by 2 instead of adding it again, okay? So that's left and right. I also have, let's see, I've got the front and the back here, 2 rectangles again. Let's analyze their edges. On the yellow here in the front, we got an edge of 13. What's another edge? And 9, 13 by 9. 13 by 9, how many yellow rectangles are there? 2, okay? And then last but certainly not least, we have the bottom and the top, which is a little hard to see when we're doing all this crazy highlighting. But the bottom shape here has a length of 13 and 7. Yeah, so 13 times 7. And again, how many are there? 2. Okay, so this is all we're doing, just finding areas, adding them together. Okay, so in my calculator, 2 times 9 times 7 plus 2 times 13 times 9 plus 2 times 13 times 7. So 542. And we're talking area, so it's square feet. Okay. We're not done. No, I'm just deciding if I want to do the next one. But those are rectangular prisms. What are the sides? That's it. What are the sides? So let's look down here. All other prisms, again, I could teach you a pretty involved formula, okay? I could talk to you about this, but I don't want to because it's a formula that you're going to forget tomorrow, okay? So I don't want to do that. Instead, let's look at our shape here. I have 2 congruent bases. What are the 2 congruent bases? Triangles, all right? So I have 2 green triangles. So let's find the area of the triangle. We have 2 triangles. How do we find the area of a triangle? 1/2 base times height. So 1/2, and what's the base and what's the height of my triangles? 9 and 12. 9 and 12. So you'll notice there's a right angle on that bottom triangle. That would also be a right angle on the top triangle. And this is important to recognize because base and height are defined as must be perpendicular. All right, so you got to find those right angles. There's your base and your height of the triangle. 15 would be the hypotenuse, so we don't want to use that. But 9 and 12, so 1/2. 9 times 12, and we have 2 triangles. Then we have 3 other shapes. What are the 3 other shapes? Rectangles, yeah. So I have a rectangle here at the back. I'm going to call it at the back, outlined here in black. How do we find the area of a rectangle? Yeah, base times height. I know it has a 9. What's the vertical edge? 16. Very good. So 9 times 16 for the black triangle. Black rectangle, excuse me. I have another rectangle. I'm going to highlight that one in purple. That's sort of the back right side if you sort of see it like I'm seeing it. So there's another purple rectangle we're going to add to it. And what are the edges on the purple rectangle? 12 by 16, 12 by 16, 12 by 16 for the purple rectangle. And then the very front, coloring the whole thing pink in front, I have another pink rectangle. And what are the edges on my pink rectangle? Yeah, 15 by 16. All right, 15 by 16. And this is all we're doing. All we have to do is add up all the shapes. Okay, we have 2 triangles and 3 different rectangles. And if you can visualize that, then that's all you need to know. I don't need to teach you any extra formulas. Okay, so in my I can type all this into my calculator if I want. What is 2 times 1/2?
1.
It's just 1. Those reduce, and 9 times 12 is 108, I think. Anyway, so it's 108 plus 9 times 16 plus 12 times 16 plus 15 times 16. So be careful, I've got lots of pluses in there. And so we get 684 meters squared. Okay. Is this hard? No. So what happens is, and the reason I don't teach these more complicated formulas is because it's just unnecessary. And the way that we deal with surface area these days is really not to use a three-dimensional figure at all. And in fact, it's to take apart that three-dimensional figure instead of looking at it as a 3D figure. And what we do is we just sort of open it up and lay it flat. And this is called a net. It's like the recipe for the three-dimensional figure, and so it's a pattern. So I can lay it flat, and when you see it flat, now what shapes do you see? 3 squares in this particular case, and 2 triangles. All right, and so what we've done is instead of considering the whole three-dimensional figure, we're just going to say, hey, let me cut it on the seams and lay it flat, and then it's a lot easier to see the different shapes, right? So same idea, I've just given you a net here now that we're going to find all the different areas. And what do we do with surface area? How do you find surface area? You add all the areas. That's all it is. Add up the areas. And so when you look at number 5 here, I have this first rectangle. What's its area? 10 by 7, which is 70. If you have the picture, you can just write the area inside. It makes it so nice. What about the triangles? How do we find the area of the triangles? 1/2 base times height. And so be careful when we're looking at these triangles here. What are the base and the height? Yeah, again, there's the right angle. So 7 by 9. Those would be the base and the height. 11.4 is a slanty height. It's not perpendicular. Don't use that. So that area is going to be 1/2 of 7 times 9. What is half of 63? I don't know. 31.5. 31.5. So this is 31.5. What's the other triangle? Same thing, 31.5. All right, what about this rectangle in the middle? Yes, it has an edge of 9.
So are all the sides congruent to each other?
No, don't assume that. We have to look carefully at our picture. This side is 9, and across the top, what's the length across the top there? 10. It matches the 10. What's 9 times 10? 90. Okay, so definitely take your time to really think through. And then we have another rectangle here. And what are its edges? 11.4 by 10 across the top, which is 114. So how do we find the areas? Add them up very easily. So I'm just going to, once you fill in your picture, it's just really easy. 70 plus 90 plus 114 plus 31.5 plus 31.5. 337. Perfect. 337 meters squared. All right. So that's what we're doing. We are just adding areas. All right. I think you've already done far harder things. Questions so far? No, it's adults math. We're not done. Let's look at the number 8. No, it's not really number 8. This is just a triangular base pyramid. They tell you in the picture that all of these are equilateral. What does equilateral mean? Yeah, they're all the same too. So they're all just equilateral triangles. They're all congruent triangles here. How many triangles do you see?
1.
4. Oh, one giant, but 4, 1, 2, 3, 4 little guys there? Yeah. All right. So how do you find the area of a triangle again? 1/2 base times height. When we look at these triangles, the dimensions are a little bit funky how they have them labeled here. But if I have this triangle right here that I'm outlining in black, what's its base? 10 feet. What's the height of it? Yes, it matches the height here, all right? So 8.66. So it's going to be 1/2 times 10 times 8.66. And that's the area of one triangle. So that's going to be 5 times 8.66, which is 43.3. So how do we find the total area? Times it by 4, exactly. So there's 4 of those exactly equilateral triangles. 43.3. So there's 4 triangles that are all the same size, so 4 times 43.3 is 173.2 feet squared. Questions on that? You're getting it, right? Just adding areas.
That's the whole triangle, the big one?
Yes, the 173 is all 4 of those little triangles added up. Yeah. All right, so the one that you do need to know the formulas of, and these are essential, are the formulas for the surface area of a cylinder. And so you want to make sure you know this formula. I'm going to talk about where it comes from. So first of all, when we look at a cylinder, there are 2 bases. And what shape are those 2 bases? Circles. What's the formula for area of a circle? Yeah, the area of a circle is pi r squared. And you can see that if I want to find the surface area, oh, I have it right here, actually, it'll work. If I want to find the surface area, that's part of the shape. So it has 1 circle and another circle. All right, so I need how many circles? 2. All right, right there, we've got 2, and what's pi r squared? The area of a circle, all right? So we've got 2 circles, 2 areas of circles, and then when we unwrap the cylinder, all right, you can imagine a soup can, and if I cut the label and I open it up, what shape is it? It's a rectangle. That's exactly right. It's just a rectangle. So I know that to find the area of a rectangle, I need to know the base and the height. Well, the height is the height of the cylinder, but I need to know this long edge that's wrapping around the circle. Around the circle, that long edge is the same as, what is the circumference of the circle? Yeah, circumference is the distance around the edge of the circle. That's what circumference is. And so when I unwrap these sides, that is lining right up with the circumference. So this long edge of our rectangle is simply circumference. And circumference, what's the formula for circumference of a circle? 2 pi r. 2 pi r. And so right here, 2 pi r, that's the circumference. And then times the height. So there it is, circumference times height of your label. All right? So that's where the formula comes from. It's not complicated at all. Makes pretty good sense when you think about it, okay? And so this is the formula that you do need to memorize. If we want to find the surface area of a cylinder, the surface area of a cylinder is 2 pi r squared plus 2 pi r h. And we can go ahead and plug in. What is our radius? 11. Our radius is 11. R equals 11. So we're going to plug 2 pi, and our radius is 11. Don't forget to square it. Plus 2 pi times 11 for the radius. And what's our height? Yep, the height equals 26. So times 26. That's all the math you need to write down. The rest is calculator work. I don't think so. I think they're going to say round. So 2 pi times 11 squared plus 2 pi times 11 times 26. Did you know where pi was? The pi right here above the caret symbol in blue. So, all right, just making sure. All right, and then, so that was 2557.3 yards squared. Okay. Number 10, what's the radius? 7.5, good. That was 15 divided by 2. What's the height? 9. And again, height is going side to side. You might be like, that's not what height is. Height goes up and down. We can rotate our figure, right? You have to understand that we can rotate the figure. The height is actually defined as the height between bases, or the distance between bases. So whether it's laying on its side or whether it's standing up, it's always the same. It's the distance between the bases. That's a better way to define height, okay? So for surface area, it is 2 pi radius squared, so 7.5 squared, plus 2 pi radius 7.5 times height of 9. All right, so 2 pi times 7.5 squared plus 2 pi, whoops-a-daisy, 2 pi times 7.5 times 9, and we get 777.5 meters squared. Okay, do you have questions for me?
Yeah.
All right. Keep those notes handy.